Hello everyone, my name is Dennis Ganzaroli and I am a data scientist with over 25 years of experience. I worked for many years at Swisscom in the telecommunications sector in the German-speaking part of Switzerland. Today I would like to introduce you to my book, The Visual Data Language, from the series The KNIME Way. This book deals extensively with KNIME, an open-source software for data analysis that is used in modern data engineering and data science. The book is available as a paperback, hardcover, and for the Kindle e-reader, and it is also conveniently available through the Kindle app on tablets, PCs, or Macs. This book is intended for business analysts and data experts who are already working with KNIME or are just getting started. It is therefore suited for both beginners and experts. There are also practical real-world application examples that you can easily download and access from my KNIME Hub and experiment with them directly on your own computer. We will go into much more detail about this later. And I have to say that so far, everyone who has bought the book has also downloaded the examples. This means that the book is actually being read. It also explains how to set up a computer for data science, from the operating system to the software packages, all the way to preparing a workstation. But the book is also about my career path in the world of data. What was the actual reason I became a data scientist? I studied psychology and computer science at the University of Zurich in Switzerland. During my studies, I did an internship at GFS, that's a market research company, and there I learned to use SPSS, a statistics program that was very well known at the time. Back then, nobody wanted to work with data. It was too abstract, too complicated, so I told myself, if I can do this job, I'll always be able to find work. At that time, I was still a student. I needed the money. Well, in 2012, data scientist became the most sexiest job in the world. But here we were, still in 1998. Yeah, that was still ahead of us. The second reason has to do with this movie, Back to the Future Part 2. Maybe many of you know it. In the movie, Marty McFly travels to the future and buys the sports almanac there. So he can bet specifically on games whose outcomes he already knows, but then he has to throw the sports almanac into the trash because Dr. Brown insistently tells him that you can't just change history. The book then ends up in the hands of the villain Biff, and he becomes incredibly wealthy by placing winning bets. He then becomes the luckiest man on earth thanks to the sports almanac. Well, building a time machine seemed a bit difficult to me, but times were about to change because 1999 saw the beginning of what you might call the age of data mining officially began. In fact, with the introduction of the CRISP model, the cross-industry standard process for data mining, the era of data mining truly began. And that was also when I started exploring this topic myself. A famous book at that time was Data Mining Techniques by Barry and Linoff. Back then, it was practically the Bible. But around that time, the first data mining apps also came onto the market, which were later renamed predictive analytics, or, as we say today, machine learning. And there was one piece of software that fascinated me. It was called Clementine and also came from SPSS. It had everything you needed. There was just one problem. A Clementine license cost money, 65,000 Swiss francs, or at the time, 65,000 euros. My response? I started my professional career at SPSS in sales as well as in technical support as a consultant. My goal was to learn as much as possible about data mining. I have worked for various companies, including as an external consultant, In 2009, I was finally hired by Swisscom. Again, this was because I knew how to use Clementine. But at the same time, while I was working at SPSS, I also discovered the software 𝗫𝗏, which at that time was still known by its full name, Constants Information Miner. I told my boss at SPSS, I told him that there was a program that was like Clementine but free.
And he said to me, "Keep your mouth shut. Don't let anyone find out."
So I told myself I want to learn 𝗫𝗏 because it's open source, and that way I wouldn't have to rely on those incredibly expensive licenses anymore. Then it also became a hobby of mine, which I combined with sports predictions because I still had this back to the future idea with the goal of winning bets. And that's where this sentence comes from, which I later said at a KNIME summit.
If you want to be a data scientist, change hobbies.
Because to be successful in data science, you have to fully commit yourself, just like in any other field. But if you can combine it with a hobby, it's even better. Well, back in those early years, I actually ran a website called 𝗏𝗏𝗀𝗏, where I sold sports predictions to bettors. In addition to that, I also regularly took part in several tipster competitions, and I consistently did pretty well at them. That's why I had already tried out 𝗫𝗏, because I also made the predictions using 𝗫𝗏. Why was it so important to have such a hobby back then? Because in 2013, when my boss at Swisscom switched departments to build a new area for sales steering, he wanted me to go with him. There was just one problem. The department had no budget, but the assignment remained the same. To create the reports in order to measure the KPIs of sales, and so on. And that's why I introduced KNIME at Swisscom. And I learned something very important, that the licensing costs are of vital importance. But why have I always had this passion for visual programming? Because visual programming is a language that, better than any other, describes the ETL process, which we can see so clearly here on the left side. You load the data, transform it, and then create the reports. In fact, one day my own wife, while I was busy working with 𝗫𝗏, curiously asked me, "What exactly are you actually doing with all these hieroglyphs on the screen?" And she immediately understood that I was using a visual language to work specifically with all this data. If we then compare these two images here, which one describes the ETL process better, the written Python code here, or rather this 𝗫𝗏 workflow? Now this is a cheat sheet for 𝗫𝗏 showing the various nodes that are available exclusively for data transformation. So only for data wrangling or data blending. Each individual data transformation is represented here by a specific node, right? This node can then perform a very specific task, for example, at the beginning, reading in the data, or afterwards filtering, aggregating, and so on. So the nodes are basically like words for working with data. There's also an entire section in the book about how to learn 𝗫𝗏. From a range of available courses to helpful cheat sheets, books, articles on Medium, and even YouTube videos, everything you need is covered. Here on the right side, for example, you can see all the cheat sheets available for 𝗫𝗏. But there's also a chapter dedicated to hardware. Yes, because if you draw a comparison to a truck driver, for example, my uncle used to be a truck driver, but he was also a mechanic. Yes, because if the truck broke down, you had to be able to fix it. And anyone working with data should also have an understanding of computers. That's why in this chapter I explain how to configure a computer for data science, from the operating system to the software packages shown here, all the way to setting up your own workstation. Yes, now let's take a look at the practical examples described in the chapter 𝗫𝗏 in action. We have personal finance, which analyzes your own expenses and income using KNIME and Excel. Then there's sales reporting, which integrates data from a database and builds a dashboard on top of it. There's also weather analysis, which loads data using loops or through an API and compares temperatures over time. Financial data automatically monitors stock prices on the stock exchange, and sports analytics, on the other hand, creates forecasts for soccer matches. In the end, in advanced visualization, the legendary Minard map is recreated using AI, that is, with the artificial intelligence of KNIME and Python. The workflows can be downloaded from my KNIME Hub page, which you can also find in the video description. And then once they are downloaded, you can also load them onto your own computer, whether it's Windows, Mac, or Linux. If you want to buy the Kindle version, you can easily search for the title, The Visual Data Language, on Amazon.com, or follow the direct link provided in the video description. Now let's go on and take a closer look at some of the examples.
And we'll start with the first example, personal finance, which is a simple example to get us started. So let's open it, and I have to say, this is the most important workflow of my life. Yes, because it's about analyzing our expenses and our income. Thanks to this workflow, we were able to buy a house, pay the mortgage, and so on and so forth. So what does this workflow do? Well, I downloaded the transactions from our banks, the ones from the account in Switzerland, the ones from the account in Italy, the credit cards, and then I matched the spending categories using lookup tables. Here you have the categories in German, in Italian, and then in English. I convert everything into English. Here there's a converter from euros to Swiss francs. I combine everything into one table and then save it all in an Excel file, which I can then update from month to month. In the end, I have this Excel file here, you see, with the monthly values, which I can then compare with the budget estimates. Sales reporting. In this case, we're dealing with the well-known Northwind database, which is commonly used as a primary example in Microsoft Access. We're now going to build a dashboard based on it. Many small businesses still use Access to organize and manage their customers and sales. So this example can be useful for many people here. You can see that we're loading the Northwind database. This is a Microsoft Access database file, and we're reading the orders table from it. Without using any SQL, we can use this specific node right here and manually select the orders table. We can load it here. For the details, however, we can also write an SQL statement that selects only these columns here. And this also calculates the revenue. So the sales figures. Then we can simple merge these datasets using the joiner by using the unique index of the order ID, that is, the key of the order ID. The same applies to customers, products, and categories. When we merge everything together, in the end you will get this table from which we will select the data up to May 31st, 2025 to build our dashboard. The dashboard you see right here is created to compare this year's sales figures with those of last year, and with the orders from this and last year, the top 5 customers and the top 5 products. And all this information is processed in this special component, which we can open together here. And how this component works is explained in a very detail in this book. The weather analysis originated from a discussion we had in our village, where we talked about how this year was much warmer than the last. Here, I'll show you 2 different methods you can use to answer this question. In the first workflow, I downloaded the average temperatures from our village here since January 2024. There are a total of 19 files, which I then load one by one using a loop and combine them all together. Then, using a line chart, I can perform a detailed analysis of the average temperature from 2024 up to today. Here you can see that the highest values are more or less the same as the peak values of the current year. When I then take a closer look at the specific differences between the months of this current year and those of last year, we can clearly see that there were several significantly warmer months this year, but there were also quite a few notably colder months as well. This year compared to last year. If you then calculate the difference in average temperatures from last year to this year, we see that the difference was 0.038 degrees Celsius, which honestly is not very high. And so the question arises, where has climate change gone? To better answer this question, I have a second workflow here. Here I am analyzing 13 Italian cities that are representative of all of Italy. With this node here, I can calculate the geographical coordinates based on the city name. Then I combine everything with this table here, which retrieves the data from 2015 to 2025. With the cross-join, I can create a combination between cities and geographical coordinates, and using this date, I then build a specific path, which I subsequently query with the 𝗏𝗏 API by simply retrieving all the individual average temperatures of the cities. From these two arranged sets of data, I create a loop, and in the end I have the average temperatures for each city and each date, which I then save in this CSV file. Here I have also saved the temperatures from 2005 to 2025 and compared the cities over the years. I see that the average temperatures were lower in 2010 and higher in 2024. When I compare the average temperatures of the last 20 years with each other, I clearly notice that the average temperature has more or less continuously increased by about 1.5 degrees Celsius. In our next example on financial data, we will automatically download current stock prices from the internet and then calculate so-called moving averages as key figures because we want to thoroughly test various trading strategies. Right here, we have the major tech giants NVIDIA, Apple, and Google. And on this other side of the chart, we have all the relevant data spanning from the year 2022, all the way through to 2025. We bring everything together with this cross-joiner, just as we did earlier in the weather example, and we build a path that we use. We then call this at the API of finance.yahoo.com, which, however, is not official, but this method still works. Then here we see the symbol for NVIDIA with the respective date and the price. We add the simple moving average over 50 days and another over 200 days, which we then find in these two columns at the end here. You can also adjust these time windows. You can set it to 100 days, 300, or whatever you like. Then we create a loop and specifically select the prices for Apple, which we then visualize and analyze with a line chart. And as you can see, the green line is the 50-day moving average, which crosses the 200-day average from below. And this is what's known as a golden cross in the stock market, a signal that you can buy. On the other hand, if the green line crosses the yellow line from above, that's called a death cross, and that's when you should sell. See? With this strategy, you could have made money as well. But that's no guarantee. Be careful, it doesn't always work. You always have to check it with your own data. Next example, sports analytics. Here we create our football predictions. We use the results from the 2023 to 2024 season of the English Premier League, which we simply retrieve here via the following link on the football data website. And then we divide the matches into two halves, the first half of the season and the second half. In the first half, we calculate the table of points earned, goals scored, and goals conceded using the statistical values listed here. Then we make a prediction for the second half of the season. Here, we add all the values, create various indicators, and then use this specific indicator of goal difference. We use the goal difference to create a model with the rule engine, which then states, if the difference between goals scored and goals conceded is greater than 6, it will be a home win.
If it is below -8, it will be an away win, and for values in between, it will be a draw. With this model, we managed to correctly predict 55% of the matches. If you compare this to the fact that, on average, between 45 and 46% of matches are won at home, you can say that our model performs quite well. However, using this model for betting does not guarantee that you will win every time. We have just seen how to calculate football predictions using the values from the table. Now, let's get some active support from artificial intelligence to create a so-called ELO rating for our predictions. The ELO rating is also used in chess and tennis to calculate the value of players, but it is also applied in football in the so-called World Football ELO rating to determine the value of teams. This is the prompt, which is written in English, and we will use it in this context. Here we see the prepared Python script. We will now open this together, and then we need to establish the necessary connection here. With the AI, we then enter the prompt and start it. And then, after waiting for just a moment or two longer, you will see that the code should actually begin to appear right here on the screen for you to see. As you can see, here it is already visible, and we can go ahead and run it directly without any further delay or additional steps required. And now, 2 columns are added here with the value of the ELO rating, starting at 1500 for all teams, which then adjusts from game to game. When a weaker team beats a stronger one, it gets more points, while it receives fewer points if it beats a team at the same level. In the next example, which is a bit special, we will try to recreate the Minard map. For those who are not familiar with it, the Minard map dates back to 1869 and depicts Napoleon's march to Russia, combining various elements. First of all, the route. Here you can see the advance all the way to Moscow and then the retreat of Napoleon's troops in black, who were very numerous at the beginning. And the narrower the line becomes, the greater the losses were. Down here we can see the temperatures the army was exposed to. And even today, it is very difficult to recreate this, whether with Tableau, Power BI, or even with Python. But with the help of AI and Python, you will see that we will manage to recreate it. The trick is to use 3 different layers, which we then superimpose. These are 3 graphics that were created with Python using this code here, which was generated by AI based on prompts. Here we can see the cities depicted. Here you can see the temperatures, and here the march of the troops, the advance in brown, and finally in black, the bitter retreat. And when you combine and merge these 3 different sections of code, you end up with this graphic here, which may not be absolutely identical to the original map, but it comes very close to the original.
Thank you very much for your attention. Let's stay in touch. Subscribe to my YouTube channel or find me on LinkedIn. Search for Dennis Ganseroli. Find a copy of my book on Amazon or at many other local bookstores across the US, the UK, and around the world. See you next time, and may the data force always be with you.